So solving rational equations. All right, so rational equations, just equations that have fractions in them, and we've got to take our knowledge of fractions and simplifying and adding and subtracting and put all that to work here to solve these things. But not every problem requires all of that work. Some of them require more than others. But we've got to also remember back when we were doing simplifying, we found those excluded values. Those are important when you're solving because excluded values are going to be restrictions on what you can get as answers or what you actually cannot get as answers for this. So let's start with an easy one that doesn't have any restricted values and is more like something you might have done in 7th grade. So that's definitely 7th grade kind of problem. Nothing just extremely strenuous there. That one does not have restrictions or excluded values because what's not in the denominator? Somebody said it. Be a little more confident in it. Where did excluded values come from? From what in the denominator? It had to be a variable in the denominator to have an excluded value when we were doing that simplifying stuff. This one does not have a variable in the denominator. So there is not a restricted value or an excluded value for this problem. So we don't have to do anything to find it. All right. The only thing we have to do is solve this. If you remember back in 7th or 8th grade or 9th grade Algebra 1, this is a proportion. Y'all remember how to solve proportions? What do you do? Cross multiply, yeah. Bottom times top, bottom times top. So we get 11 times 3x, 33x, 8 times 6, 48. And then how do you solve that? Divide by 33 on both sides. And then try to simplify that. 48 and 33, both divisible by 3. 3 goes into 48 16 times, 33 11 times. And there we found our answer. So there we solved a rational equation. If it's just one fraction on one side and one fraction on the other side of the equal sign, that same process can be used. We go to example B, go to a little bit more difficult problem, probably still an Algebra 1 problem. Is that still a proportion? Yeah, it's still one fraction equals one other fraction. So that's a proportion. The solving method still works. Where we're taking it to the Algebra 2 level is when we start talking about these excluded values or these restrictions on the domain. Those mean the same thing. So excluded values for this one are going to come from the denominators. And this one has excluded values because what is in the denominator? Variable. Okay. Anytime there's a variable in the denominator, you're going to have excluded values. So how did we find those when we were simplifying? We took the denominator and set them equal to what? 0. This one has two different denominators, so we're going to set each one equal to 0 and solve it. So one excluded value is -1. What are you doing? Oh my gosh. All right. And the other one, you subtract 5. You got 4x is equal to -5. Oh my goodness. All right. And then divide by 4. Yeah. So another excluded value is -5/4. What that means is that x cannot equal -1 and x cannot equal -5/4. If we get that either of those as an answer, we're going to throw it out because it creates in the original problem, division by 0, and that's an undefined operation in math. So that's why we're finding those. So we're going to find those excluded values first, and then we'll compare our answers to the problem to those. If one of those exists as an answer, then we throw it out. Okay? All right, so there's our excluded values. Now let's do the work to solve the problem. So I'm just going to copy that down here. We'll have to flip back and forth. All right, so I said this was still a proportion, so we still cross multiply. So 9 times x plus 1, 3 times 4x plus 5, right? So that'd be 9x plus 9 equals 12x plus 15, right? Because that's distributive property is what that is. And now how do we solve this problem? Get x by itself. So we're going to get like terms together, numbers on one side, x's on the other, and work from there. So I would subtract 12x. Doesn't really matter. And I'm fine with you doing more than one step at a time. So I'm subtracting 12x to get it over here and moving the 9 over there with the 15. That's negative 3x. And then 15 minus 9 would be 6, right? Last step, divide by negative 3. X is negative 2. Is that one of the excluded values? No, so we're going to keep it. That's an answer we're going to keep. If it were one of the excluded values, you'd throw it out. If you end up throwing out all of your answers that you find, then there's no solution. That can happen because it's an equation. Sometimes they have no solution. All right. Let's take the same idea, same kind of problem, and up it to a little bit more of an Algebra 2 level. 1 over 2x plus 5 is equal to x over 11x plus 8. So, will this problem have excluded values? Yes, we know it will because it's got x's in the denominator. So let's find those first. So when it's a proportion like this, where you got one fraction equal to another fraction, just go ahead and just set the two denominators equal to each other, or equal to 0 separately. Okay. 2x plus 5 equals 0. 11x plus 8 equals 0. Solve those. X is negative 5 over 2. That's one restriction or excluded value. And the other one. Hey. Thank you very much. And then divide by 11. Not negative 11, but regular 11. And the other restricted value or excluded value is negative 8 over 11. I kind of bounce back and forth between saying excluded values and restrictions because in college algebra, we just call them the restrictions. In Algebra 2, they use the words excluded values some and restrictions other times. So they're the same thing, though. So when I start bouncing back and forth. Now, to solve this, what do? Cross multiply, just like we did on the previous problems. Because it's one fraction equal to one other fraction. That's when we can cross multiply. So when I do that, x times 2x minus 5 is going to be what? 2x squared plus 5x. Good. And the other side is just 11x plus 8 because it's 1 times that. Okay. Now, this is where it gets to the Algebra 2 part. You've got to recognize how to solve that problem. Because the past two problems, we didn't have to think about it too much. It's just that we just had to get x by itself. What's different about this problem? It's got an x squared in it. So if we're going to solve something that has x squared in it, what do we need to get it equal to? 0. So that opens up factoring or quadratic formula to solve with. Okay, so let's get it equal to 0 by subtract 11x and subtract 8. So I'm just doing all that in one step. So there's a 0. We have 2x squared minus 6x minus 8. Now, what method do you want to use to solve this? X method would be good. So if we're going to think about factoring, what's the first thing we should look for? Greatest common factor. The 2x squared, negative 6x, and 8 have something in common. 2. So I can pull the 2 out. That'll make my X method a lot easier when I pull that 2 out and allow me to use a shortcut as well. Because now I do the X method on this part. Need it to multiply to be negative 4 and add to be negative 3. What does that? 1 and negative 4. And because there's nothing in front of x squared, now I can use that shortcut on my factoring, and my factors are x plus 1 and x minus 4. That 2 technically is still there, but does it affect our solutions? No. The only time it would is if it had an x on it. So this GCF that doesn't have a variable, it really just goes away. The math that makes it go away is dividing by 2. So it's just x plus 1, x minus 4 equals 0. You could have actually divided by 2 at this step when we factored it out. It'd been the same math working. And I'm fine with that. It doesn't matter which way you do that. Okay. Now, what do I do with each of these factors? Set them equal to 0. So x plus 1 equals 0. X minus 4 equals 0. X equals negative 1. X equals positive 4. Does either of those match our excluded values? No. Our excluded values were negative 5 over 2 and negative 8 over 11. Definitely not the same. So I'm going to keep both of those answers. Got 2 answers for that one. Okay. So that's going to come up. Solving quadratics. Okay. All right. Now, one fraction equal to one fraction, cross multiply to solve. That's the easiest ones to do. When it gets a little tougher is when we've got more than one fraction on each side. So let's look at some of those. Let's start with 5 over x plus 7 over 4 equals negative 9 over x. Okay. So this one is not a proportion because you have more than one fraction on one side. Okay? So we can't just cross multiply and solve it. Okay? What we've got to do when you've got addition and subtraction with fractions is find what? Not very. Least common denominator. And so we need to find the LCD for those fractions. What we want to find is the least common denominator for the entire problem. If we can get the denominators the same on all the fractions, then we can deal with just the numerators. Okay? So we got an x, a 4, and an x. None of those really factor, right? So there's not any factoring to do to get that. But so our common denominator would be what? 4 times x. Remember, if they don't have anything in common, you just multiply them together, and that's your common denominator. So our common denominator is going to be 4 times x. Okay? What we do then is we take that common denominator and we find our excluded values with it. Okay? Excluded values come from taking your common denominator and setting it equal to 0. Whatever your least common denominator is, set it equal to 0, and that will find your excluded values or your restrictions. Okay? Restrictions, excluded values, the same thing. So this is an easy solve. X is equal to what? 0. That's an easy one. So if we get 0 as an answer, we know that we're going to throw it out. So x equals 0. Okay? Now we take that common denominator and we need to get everybody to have a 4x on the bottom. What does the first fraction need? 4. So the bottom needs a 4. That means the top gets a 4. Okay. What does the second fraction need? X. Bottom gets an X, top gets an X. What's the third fraction need? 4. Bottom gets a 4, top gets a 4. Okay. Multiply that out. So we got 20 over 4x plus 7x over 4x equals negative 36 over 4x. Okay. So we've taken every fraction and got the common denominator on it. Okay. So that's your next step. After you've done that, you can throw the denominator away. And the only problem you have left is the numerator equation. The numerator equation is 20 plus 7x equals negative 36. Okay. So you've got to get everybody having the same denominator. Once you do that, you just work with the numerators. You set up the equation with just the numerators and solve it. Okay. So we're taking this one, looks a lot like the ones we've done earlier, like example A and B. So what do we do to get x by itself here? Subtract 20, good job. So we got 7x is equal to negative 56. Last step, divide by 7. Negative 8, good job. Does that match our excluded value? No, so we're going to keep that.
In that equation,
Which one? The original? Okay.
Did you not specify that on both sides?
You could have, and it could have turned in because they had these two had a common denominator. That's good that you see that because these two had a common denominator, you could have put those together and ended up doing the same kind of work there, or cross multiplying maybe. But that doesn't always work. If this was x plus 1 here, you definitely couldn't do that. So I like what you're thinking about there. That's good. This process is going to work no matter what. What you're doing is kind of a special case kind of idea. So good thinking though. All right, let's look at one that's a little more interesting. Maybe it's a good way to put it. Example E. Let's say we had 1 minus 8 over x minus 5 is equal to 3 over x. This is definitely one that we couldn't do that with because of the all three of them have a completely different denominator. 1 is not written like a fraction. How do I write it like a fraction? Just put it over 1. Okay, so anytime you got a number there that's not a fraction, it can help you we're dealing with fraction problems. That's what we're doing. So make everything look like a fraction. Okay? Now, will any of the denominators factor? No, there's not a GCF to that. That doesn't break down. That doesn't break down. So we're good there. So we're always going to look for that first. The next thing we're going to find is what? Least common denominator. That's the next step. So least common denominator, if all three of them are different, then what's the common denominator? All of them multiply together. So x times x minus 5, technically times 1. But multiplying by 1 is not going to change anything. So this one actually ends up saving us a little bit of work. Got x times x minus 5. Okay? Now, what do we do with that before we start working the problem? All right, get our excluded value. Set it equal to 0. X minus 5 equals 0. So we're doing that because that would tell us what numbers will give us division by 0, and that's the only number that we cannot divide by. Okay? So division by 0 is definitely an undefined operation. So we're setting each of those factors equal to 0. It's the easy part. That one's done. X can't be 0. Bless you. I've learned that Molly sneezes 3 times every time she sneezes. And at about 8:30 every day. So, X can't be 0. X can't be 5. If our answers match that, we're going to throw them out because those would give us division by zero in the original problem. Division by zero is undefined. Okay, now, left side has got two fractions on it that are subtracting. So to put those together, I need to be able to get a what? Common denominator. So the first fraction needs the right denominator. We've already found that right denominator. So 1 gets the x and the x minus 5. Good thing it's a 1 because that makes the math easy. But whatever the bottom gets, the top gets 2. What does the second fraction need? Just an x. The third fraction, x minus 5. Okay? I'm going to multiply that all out. I'm not going to multiply out the denominator because remember we're going to drop it in just a minute anyway, so don't waste your time. Just multiply out all the numerators. So here we have x times x minus 5 times 1. So that'd be x squared minus 5x over x minus 5 minus 8x over x minus 5 equals 3x minus 15 over x minus 5. We've got everybody with a common denominator. So what can we do with the denominator? Drop it, okay, and get rid of it. So our equation now is going to be x squared minus 5x minus 8x equals 3x minus 15. Be careful of your sign, especially when it's a subtraction problem, that you're subtracting everything that's in the numerator. This one only has one term, but if there were two terms in the numerator, you're subtracting both of them. So be careful of that, okay? Now, got some like terms here on the left side we can put together. Negative 5x and negative 8x would be negative 13x. So I have x squared minus 13x equals 3x minus 15. To solve this, what do I need to get it equal to? Why do I need to get it equal to 0? Because I got an x squared in it. Anytime I've got an exponent on my x and a plain x in there, or whatever variable we're dealing with, I've got to get it equal to 0 to solve it. Okay? And so I'm going to move the 3x and the 15. Minus 3x plus 15. There's my 0. X squared minus 16x plus 15. What are my options for solving this? X method or quadratic formula. They will both get you the same answers on this one. This one factors and does quadratic formula. So I'll do it both ways. I'll show you both. So if we factor it with the x, multiply to be 15, add to be negative 16. That'd be negative 15, negative 1, right? So x minus 15, x minus 1. X equals 15, x equals 1. Easy stuff there. So setting each factor equal to 0 and getting those. If you did quadratic formula, works the same way. I think it's a little longer here. Ted, you could do like Tyler and kind of snake yourself through your desk to get down there to it. Like a boa constrictor going through that. 16 squared is 256. Minus 15 times 4, which is 40 and 20, 60. 256 minus 60 would be 196. What's the square root of 196? How much? 14. Good. That works out great. It's got a nice one. Yes, sir.
So why are we doing the?
I'm just showing you that you could solve it either way.
Oh,
You can do factoring works, but there are sometimes when factoring doesn't work. So you need to be refreshed. Make sure you know how to do quadratic formula as well, because sometimes factoring is not an option because it doesn't work. Okay, and so we set up x equals 16 plus 14 over 2. X equals 16 minus 14 over 2. So there's our 30 over 2 is 15. 2 over 2 is 1. So we get the same two answers out of that using quadratic formula as we do factoring. Again, factoring is a great option when it works. When it doesn't work, you're stuck. You've got to do quadratic formula. So it works. It works quite a bit. So, all right. Do one that's maybe a little bit tougher. 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. Kind of stepping up a little bit here. Three different denominators. Will any of those factor? Which one? The x squared minus 9 does. So it's x squared minus 9 factor says what? Yeah, x minus 3, x plus 8. It's a difference of squares. Being able to recognize that quickly is a good thing. So that's nice because each piece of that matches one of the others, right? So that's going to make finding that common denominator much easier for each of those fractions. What would be our least common denominator? Yeah, technically it's x squared minus 9. I'm going to write it as x plus 3 and x minus 3. And we take that and find our excluded values. So x can't be negative 3. X can't be positive 3. Those are excluded values or our restrictions. Restricted values, restrictions on the domains, another way of saying that. That's what we say in college algebra. It's restriction on the domain. Now, from there, we need to fix the other fractions. Okay. This one already has both pieces, so it doesn't need fixing. What does this one need? It needs the x plus 3. So we're going to get x plus 3 and x plus 3 on the top. What does this fraction over here need? It needs the x minus 3. All right. So that's going to give us 6x plus 18 over x plus 3, x minus 3 equals 8x squared, x plus 3, x minus 3, minus 4x squared minus 12x over x plus 3, x minus 3. So that's what it looked like after you fixed the denominators for all your fractions. What's the next step? Drop the denominators. This one you've got to be extra careful on, because it's not just 8x squared minus 4x squared. It's minus this entire part. So when I subtract 4x squared minus 12x squared, that's going to be minus 4x squared, but what's it going to do?